This video is going to be a long one. We are going to cover 8 terms that will build on the future series of videos, so make sure if you are revising to have a notebook out or something similar to take some notes. If you're learning this for the first time, just watch, listen, and try to take it all in. Pause the video if you feel you need to rewatch one part again, as this will be quite fast in respect to the number of terms that we need to cover. If I go to a school and want to investigate a variable, let's say age, then I'll ask for people of their ages. If I do so here, an example could be the following: 14, 15, 12, and 16 years old. But that isn't a lot of people to ask of. My dataset will be very small if I were to only ask 4 people. So how about I go and ask the entire school? That's quite a lot. In fact, if you watched my previous video, types of data, it will be in the video's description. You would know what I am collecting is classified as primary data. You'd also know that it is very time consuming to collect data on your own for a whole school. But anyway, let's roll with it and get on with some terms. The first one is called a population. You may have heard of this, and in statistics, this means everything that could possibly be involved in an investigation. For us, this will be every student in the school that I could ask. You should also note that a population is a flexible term, in the sense that it can take different meanings depending on the context. For example, you could have items in the factory as your population, or even employees in an office. Moving on, the next term we can cover here is called a census. This is a survey or investigation in which data is taken on every member of a population. So, where the students are the population, the process of me recording data is a census. This is impractical though. What if we could just find a middle ground and just survey a couple of them, then use that data? Well, we can actually do this, and we call it a sample, a subset of the population which we use to collect data from. So, I've just taken a sample as we now know what it is. This is a different one from the one at the beginning of the video just to avoid confusion. The ages of them are 16, 15, 16, 16, and 16 years old. This is a secondary school that I'm talking about. Most have a larger range of ages, typically 11 to 16 years old. So my data is a bit off. I now need to admit that I in fact asked my friends their ages, because I'm too shy to ask anyone else. Most of my friends are in my year, hence the ages. But this doesn't really help me when I'm trying to investigate the ages of my school in general, not just year 11. Yet another term now, bias. This is a systematic error in the sampling process causing the sample to misrepresent the population. In more simple terms, the sample doesn't tell the truth, fully at least. For me, my systematic error was actually only asking year 11s and no other years. So we need to go back and rethink. We managed to go from asking a whole population, and to save time we took a sample. But in order to show the other ages as well as 16, we'll need to make sure that the sample does include that. So from my population, we'll take a sample, and of that sample, they need to fully represent the ages of my school to some extent. And here is the data: 16, 11, 14, 15, 12, and 13 years old. A much more varied sample. And this is called a representative sample, a sample that represents the characteristics of a population. In ideal conditions, you'd want a higher sample than just the 6 ages that I showed. We'll explore that part later. As part of the Edexcel specification, we were required to know the advantages and disadvantages of both a census and a sample. The same goes for AQA too. We'll start with the advantages of a census. Firstly, it will be unbiased. Like the earlier definition, it is hard to be biased when you take the whole population into account, as bias is usually more of a problem in the samples. A census is usually accurate, as all members of the population are investigated. There are no sampling error intervals as there would be for a sample. However, it does come with some disadvantages. The first is that the whole process can be time-consuming for very large populations. An example was the UK Census, where the whole country theoretically completes a questionnaire about certain details. It takes such a long time to the point where the government only does this every 10 years. If anything is time-consuming, it is always going to be expensive. The time you lose to a job perhaps, or the need to employ more people for longer to carry it out. They are the expenses that increase with time. And the last, probably the most important part, in practice we use some accuracy, as it is difficult to ensure the whole population is used. The UK Census, for example, arrives by post in most cases. It doesn't take into account the homeless or those that are hard to reach. This means that the benefits that you theoretically get from a census aren't always achieved. If we look at a sample, it will be much cheaper to conduct compared to a census, and as a result of the significant fall in data needed to process, it will naturally shorten how long we spend on it. But a sample is not completely representative, and in some cases will carry bias which will misrepresent the data. Sometimes this is just done by poor planning and preparation, but other times it could be done on purpose. We are approximately at the midpoint of the video, and so far we have covered all of these terms. It is crucial that you understand these terms before you move on, because it will help you to manage the vast number of terms that we cover in this video. A sampling unit can be defined as follows: the people or items that are to be sampled. So if we use our example of the school, the students are the sampling units of this investigation. A sampling frame is a list of all the sampling units. I do need to make a clear clarification here. The sampling frame is a list. This is a key point. It also represents all the possible sampling units, not just the ones chosen. So actually, a register, which is a list of all the students, would be a sampling frame. If we go back a bit and look at a sample, and perhaps we could see that the size of a sample is 50 students. An example, by the way. This is quite frankly simple. We call the number in your sample the sample size. Let me show another thing to you, and hopefully this will make some sense. I ask 4 football fans of their favourite Premier League team. We need to assume that there is no bias in the collection of data here, and look back at the video if you need to recap on this. I found out that there are 3 fans of Manchester United and 1 for Chelsea. That isn't really great to show someone who knows nothing about the Premier League. It just appears as if there are a smaller number of teams. I've put this back here on the top left. You should gather that the sample size is 4. Now, if we take another sample, this time I'll up the sample size to 40, we end up with a lot more detail, so I'll just output the top 6 results. We also get the respective percentages of each team. Now, for the sample of 4 with Manchester United and Chelsea, we got a 75% ratio for Manchester United and 25% for Chelsea, with no other teams. The percentages when I increase the sample size to a few more people diversifies dramatically. The point I am trying to make here, the whole country doesn't support 2 teams, we all know that. But my sample, because it was so small, suggested so. If we increase the sample size, each and every time we will see an increase in accuracy, and by that I mean closer to the truth, as if I asked the whole country. And this applies to pretty much every topic of samples. Now I realize what I just went through may have utterly confused you, and if it has, don't panic, but rather just listen to every detail on this page. A simpler example, which still captures the essence of sample size, could be the flip of a coin. Let's do some probability. So if we have some coins, what are the possible results? You might know that it is either a heads or a tails. If you also have some general knowledge, we can assume the coin is fair, and that means the probability of either side of coin landing, heads or tails, is 0.5, 50%, or a half. So if I decide to flip the coin 10 times, what are the number of heads and tails that you would expect? Pause the video and have a good think about this. Now the correct answer, and what we expect, is called the theoretical probability, and this was that after 10 flips, you'd expect 5 heads and 5 tails. But I actually did this in real life, and what I got was 4 heads and 6 tails. So what's going on here? Well, If you have ever flipped a coin yourself and perhaps hedged your bets to pick a side, only to find out that with your appalling luck you didn't land at all, you'll understand that what happens in theory doesn't play out in real life. I ran the coin through a simulation from 10 to 1,000 times. The main increments of the powers of 10 are shown in this table here. Look at the percentage of the heads. We expect a 50% chance for the first example, and we saw that it was only 40%, right? So this was 10% off. That's quite a bit, to be honest. Well, when it was flipped 100 times, we got 54 heads, with a 54% of heads. Now, this is much closer, though still far off from the 50% we would expect. And with even more flips, 1,000 this time, we get 495 heads at a percentage rate of 49.5%, which is extremely close to the 50% if we compare it to the 40% at the beginning with only 10 flips. And this graph here shows it perfectly. At the beginning, any sample, if very small, is open to such large misrepresentation and varied characteristics. The percentage of heads fluctuates closer and closer to 50% until it pretty much reaches it at around the 1,000 mark. So now you've seen two examples, if you watched both. They both portray the same thing with different contexts. As you increase the sample size, the accuracy increases. If there is one thing about sample size that you take away from this video, I want it to be this. A higher sample size mostly means an increased accuracy. When would be the better representation of the diversity of fan support across the country in the Premier League, or just how the probability of a heads is 50%. The sample size, dependent on how large, can represent this or not. That's all the terms done. If you're revising, have a go at these questions that we're going to go through now and see if you can get them correct. You can then go ahead and try out the worksheets at the video's description for free. If you're learning this, now's the time to test your learning. In this question, we are told that Alex wants to inspect the quality of pies at a factory. He decides to check out all of the pies. What term is given to the inspection of all of the pies? Well, if you look at the definitions, we can identify that our population is the pies, and that the process of Alex inspecting the pies is a census. For part B, Alex assigns each pie a unique serial number. What is the sampling frame in this context? Well, the most important part about a sampling frame is the fact that it is a list. So we can put that it will be a list of all the pies and their respective numbers. If you've made it to the end of the video and want something to summarize what you have covered today, then this slide has all the definitions explaining what the specification requires you to know. Thank you for watching this video. I hope you found it useful. Be sure to subscribe for future uploads, and please share this with someone who will benefit from this. If the channel gains more reach, then naturally as we get closer to the mocks, I'll make more videos.